Hello student, today we'll discuss about the units of refrigeration and reverse Carnot cycle. This topic is covered in unit refrigeration in thermal engineering 2 subject. At the end of this lecture, you will be able to define the term turn off refrigeration, understand the working of the reverse Carnot cycle, know the COP of the reverse Carnot cycle, and at the end identify the difficulty in operating reverse Carnot cycle. Now, what is the unit of refrigeration? The practical unit of a refrigeration is expressed in terms of turn of refrigeration. Now, question is that what is the one turn of refrigeration? It is the one of the IMP question for GTU examination as well as for interview questions. Now, in the slide, we already see there is a one ice is there. We take as a ice as a 1 ton ice. Now when the 1 ton ice is uniformly melt at a 0 degree Celsius in 24 hours, it will produce the refrigerating effect. The amount of refrigerating effect produced by uniform melting of a 1 ton ice at a 0 degree Celsius in 24 hours is known as 1 ton of refrigeration. Once again, as the amount of cooling effect, also we can say that a cooling effect or refrigerating effect. The three parameter is very much important when you define the 1 ton of refrigeration. Three parameter is that one is a 1 ton of ice, another is a 0 degree Celsius, and the third one is a 24 hours. So it is the amount of refrigerating effect produced by uniform melting of a 1 ton ice at a 0 degree Celsius in 24 hours. That is known as a 1 ton of refrigeration. Now turn conversion into kilowatt and kilojoule per minute. As we know that the latent heat of ice is 335 kilojoule per kg. When the 1 ton ice is melt, it required latent heat because solid is converted into the liquid. So there is a latent heat will be in the picture. The amount is required 335 kilojoule per kg for 1 kg of ice. When 1 ton of ice is melts for in a one day, it will absorb 900 into 335. This 335 is for 1 kg. Now we are melting here 1 ton of ice, so we have to take 900 kg. As we already know that 1 ton is equal to 1000 kg, but when this unit is formed, at that time 1 ton is considered as a 900 kg. So we take as a 900 kg here, and 335 is the latent heat. So when we multiply this data, we will get 301500 kilojoule per day. Now what is the amount of heat absorbed or refrigerating effect produced per hour? So 335 301500 kilojoule per hour divided by 24 hours, because in the one day we have the 24 hours. Now our target is to get the cooling effect. Our target is to get the cooling effect in kilowatt. So we have to convert that into the second, kilojoule per second. So 301500 divided by 24 into 3600, so we will get into the kilojoule per second. So 1 ton is comes around, when we calculate the whole data, we will get 1 ton is equal to 3.5 kilojoule per second, and kilojoule per second, as we know that 3.5 kilowatt. And when we convert into the kilojoule per minute, when we have the in the minute, we will get the data 210 kilojoule per minute. So somebody will ask, what is a 1 ton is equal to how much kilowatt? So at that time the answer is a 3.5. It is a round value, and 210 kilojoule per minute. Now refrigeration cycles component. In any refrigeration cycle, there are four components are present. One is known as a compressor, second one is known as a condenser, third one is known as a expansion device, and the fourth one is known as a evaporator. And the evaporator is the device where we will get the refrigerating effect. evaporator એવું ડિવાઇસ છે જ્યાં આપણને રેફ્રિજરેટિંગ ઇફેક્ટ મળે છે અને કોમ્પ્રેસરમાં આપણે વર્ક ઇનપુટ આપવું પડે છે. એટલે આ ચાર કોમ્પોનન્ટ કોઈ બી રેફ્રિજરેશન સાયકલની અંદર હોય છે. વન ઇઝ નોન એઝ અ કોમ્પ્રેસર, another known as a condenser, third one is the expansion device, and the fourth one is the evaporator. Now basic cycle first we will discuss, that is known as a reverse Carnot cycle. We already discussed this reverse Carnot cycle in the thermodynamics subject, but in the refrigeration, to start the main cycle we need to understand once again reverse Carnot cycle. So as I already mentioned, in any refrigeration cycle four components are there. These four components here in the reverse Carnot cycle, there are four components. One is a compressor, condenser, expansion device, and evaporator. The expansion device will be changed. Like in the reverse Carnot cycle, the expansion device is a turbine. When we have the another cycle, at that time the expansion device is also changed, and the sequence will be remain the same. First is a compressor, condenser, expansion device, and last we will get the evaporator where we have the refrigerating effect. In the reverse Carnot cycle, it is the ideal cycle, as we know that it's a 100% or high one of the high COP cycle. In the case of the refrigeration, we will not have this reverse Carnot cycle in actual practice. What is the reason behind that, we will understand at the end of this lecture. Now as we know that in the reverse Carnot cycle we have the four process. Out of the four, two process are isothermal process. This one isothermal process means constant temperature process. This is the constant temperature process, this is the constant temperature process. One is a condenser, is a constant temperature process, and the evaporator is also constant temperature process. And two process are isentropic. Isentropic means entropy remains same. So compressor and turbine expansion device, we will say, both are isentropic process in the reverse Carnot cycle. Okay, so we will start with the 2 to 3. That's 2 to 3. One is the compressor. So in the compressor temperature are increased. So from T2 to temperature is increased up to the T3. After that the refrigerant is goes to the condenser. So from 3 to 4, here is a heat is rejected. It is a isothermal process. After that it is goes to the turbine where the isentropic process, the temperature will be reduced at the lower temperature. Here temperature will be reduced at the one side. Then it is goes to the evaporator. In the evaporator we will have the refrigerating effect because at the entry of the evaporator, the substance, the working medium, it is at a low temperature, low pressure, and it is in the liquid form. So when it is enter into the evaporator, it will produce the refrigerating effect. How? When we have the if we blow the air, hot air, so when it is in the contact with the evaporator coil, so that hot air is converted into the cold air. Or we have the one substance to cool the particular substance when we put into the evaporator. So when this working medium, it is at a low temperature and low pressure, when it is contact into that particular substance, so that substance temperature will be reduced and we will get the refrigerating effect. And that particular working medium, it will absorb the heat from the substance, so its temperature and pressure will be increased when it is out of the evaporator. So will again it is enter into the compressor to return the to complete the whole cycle. So that is the reverse Carnot cycle. Another pictorial view of the reverse Carnot cycle is this one. As this is the compressor, the pressure and temperature both are increased. After that it goes to the condenser. Condenser is a coil, as we have the, this is the also condenser, this is the one type of coil type condenser. So here heat is reject, then it is goes to the turbine. So in the turbine the expansion processes will take place, so temperature and pressure both are reduced. So here is the color is also changed. So when it is enter into the evaporator, the working medium is at a low temperature and low pressure, so it will produce the refrigerating effect. It will produce the refrigerating effect means it gives the cooling effect to the particular substance that we will want to get cool the particular substance. After that it goes to the compression. Okay. Now, reverse Carnot cycle, COP. So as we already discussed, COP means coefficient of performance, and COP is equal to refrigerating effect divided by W net. That is the general equation. As we already discussed in the earlier lecture, the COP is equal to refrigerating effect divided by W net. Now in case of the COP of reverse Carnot cycle, we have the QL amount of the refrigerating effect, and W net, if you want to find, so W net આપણે find કરવું હોય તો heat rejected minus heat absorb કરીએ એટલે આપણને W net મળે for the COP of the reverse Carnot cycle or any cycle. સો ક્યુએલ જે છે, જે કોન્સ્ટન્ટ ટેમ્પરેચરે પ્રોસેસ થાય છે કન્ડેન્સરમાં, સોરી, અને ઇવાપોરેટરમાં. જો ક્યુએલ જે છે એ ઇવાપોરેટરમાં થાય છે. જો આપણે બેક જઈએ તો વધુ આઈડિયા આવશે. Here this is the evaporator where the QL amount of the heat is absorbed, and this is the condenser where the heat is rejected. Here is entropy change from S2 to S1, S2 to the S1. Here is change from S3 to S4, so that we will use. So QL at a low temperature, so S2 minus S1, temperature is remain constant, so we will have the only TL, and entropy is change, so S2 minus S1. So now next is a heat rejected, so TH is a high temperature, condenser is at a high temperature, and entropy change is S3 minus S4. Then again QL, so QL is TL into S2 minus S1. So as we know that S2 minus S1, S2 minus S1, and this S3 minus S4 is also S2 minus S1 from the reverse Carnot cycle TH diagram. So that S2 minus S1 will be cancelled out and will be remain TL upon TH minus TL. When we not want to use the TL and if we have the number, so at that time we can also numbering that T2 upon T1 minus T2 for the reverse Carnot cycle. This can be asked in the your G2 examination to calculate the COP of the reverse Carnot cycle, and that time two temperature will be given. So at that time you have to use this formula. One it as a low temperature and another is a high temperature. So low temperature will be at the numerator side to get the reverse Carnot cycle COP. Okay, and upon T1 minus T2. Now difficulties in operating reverse Carnot cycle. There are the number of the difficulty. We identify the one of the three important difficulty why we will not have the reverse Carnot cycle in the actual practice. આપણે જે reverse Carnot cycle હોય છે એ actual practiceમાં આપણે નથી બનાવી શકતા, કારણ કે રીઝન એ છે it is not possible to have the isentropic expansion and compression. કે isentropic expansion અને compression possible થાય જ નહીં, કારણ કે entropy જે છે એ change થવાનો જ છે. So we will not have this kind of the process where we have the isentropic expansion and compression. Another is that in the reverse Carnot cycle we have the two devices. One is a evaporator and another is a condenser. Both are heat exchanger, but it is operated at a constant temperature. So this kind of the device is not possible that it operate at a constant. એવું કોઈ device possible નથી કે constant temperature જ operate કરતું હોય. So that is another difficulty in operating the reverse Carnot cycle. And the last is the refrigerating vapor entering the compressor is wet. જ્યારે evaporatorમાંથી બહાર આવે છે વર્કિંગ મીડિયમ, ત્યારે કોમ્પ્રેસરમાં એ વેટ ફોર્મમાં જાય છે, અને વેટ ફોર્મમાં જાય ત્યારે ઇટ વિલ ક્રિએટ અ પ્રોબ્લમ ઇન ધ કોમ્પ્રેસર. ધીસ ઇઝ ઓલ્સો પ્રોબ્લમ ઇન ધ રિવર્સ Carnot cycle. So there are the three main difficulty operating the reverse Carnot cycle. So in this lecture we discuss about the units of the refrigeration, then we discuss about the reverse Carnot cycle, also we discuss about the four component in the refrigeration cycle, and the COP of the reverse Carnot cycle we already identify, and we also know the difficulty in operating reverse Carnot cycle. Thank you.